Hello everyone, welcome to Fluxray Electronics. In today's video, we are solving some basic questions of HDL bits related to Verilog for practicing purpose. So there are like some topics that are enlisted, like getting started, Verilog language, combinatorial logic, sequential logic, reading simulation, driving distance. We are like solving all that questions, but in today's video, we are like focusing on getting started and some basic Verilog questions. So let's get started. Like before starting, so there are like some instructions are like given here. Like if you want to like monitor your progress, so you can log in. So you can do that things also. So let's get started. Like by clicking here, getting started, you can start the solving questions. So this is like first things, which is like getting started. So just click here. Okay. So it's showing that step one. So getting okay, some instructions are like written here, like how to simulate, then writing code, then compiling simulations, then like after all that simulation, like what is the status, like compile error means like what is, and simulation error means like what happening actually it's showing, so incorrect circuit. So we have to focus on like success like everywhere. Okay, so there's like my status page, you can like where you can track your progress also. So yeah, let's go to like question, like the like problem statement is given. We are going to start with small bit of LGL to get familiar with the interface used by LGL bits. Here is the description for the circuit if you need to build for this exercise. Build circuit with no inputs and one output. So we don't have any input and we have one output. The output should always drive one. So we have to like drive one output. So they give the already like snippets. So yeah, they also give the range like you have to fix here. Okay, so we have to like continuously drive the output means we have to use that assign statement for our output, and just we have to continuously we require output as well. So for like one, you can like give any numbers. So like it's like logically it's written one value, or like you can give in that way like one fixed binary one. I will show like both solution how it will work. So the like best way to like is like one fixed binary one. So but the one thing is that like when we are like fixed value assigning to someone, so in RTL it's like warning it's giving, because like RTL it should there is like rule it should not be like fixed value to our like output. Okay, so we are not have to like assign, but like for this like simulation it's okay. So this is like one way. I'll press the submit button, so it will execute. Let's exhibit on quarters and model sim both. So we get the status success. So this is like timing background for selected test case. Like this is like reference one, and like what is like our code executed that like, so if both are like matches, so we does not like, so zero mismatches, that means our program is like right. So another method is like, so if you like assigning any number greater than zero, like uh, instead of zero, so it's always logic one, like 11, 12, 21. So if you assign in that way, it will be also a right. So it's always give as like logic one. Even like some negative number can be like possible. Like I'm just giving -21 here. So it's still return me a logic high. Like some warning is generated, but just you can ignore it as of now. So still status gets success. So it will not put either zero at that time. You are like, yeah, assign as like high value to any variable. So let's go to next question. So these are like two ways for like solving this. So let's go to the next question. So this is like 0. So build a circuit with no inputs and one output. That output is constantly 0. So we have to create one module where like our output like constantly 0. It's like similar to a previous one here, but they don't give like snippet like topic snippet. So we have to write some like one line. So this is like our output variable 0, and we have to assign constantly 0. So what we are like doing? So assign variable name 0 equals to 0. So this thing can be possible. Like one more thing be possible, that like one tick binary 0 also be possible. I will show you like how to write that. So we get status success. I'm not taking the timing diagram because we get status G success. But if you are like new or like just starting the very low coding, so just go with the timing diagram, like how it works. So just go with that, or like understanding the digital with respect of very low. So you can also write that in that one, one tick binary 0. This is like more accepted way or like good practicing way. So submit it. Yeah, again we get status success. Okay. So let's go for the next question. It's like wire. So this is like wire question. So create a model with one input and one output that behaves like a wire. So we have to create. Okay, they given that diagram also. So we have one input called as in. So we have to create one top module, and we have like output as a like out. So we have to in that way. It's like in our model it comes like input and it gives like output. So in short, we have to create like buffer, like not actually buffer because there is no delay. So we have to like create a model where like same whatever the input giving, the same output is like continuously driving. So this is the things. So like for continuous driving, we are using assign keywords. So what assign keywords does? So whatever the left hand side of assign is like we are writing output, and whatever the right hand side of the equal we are giving the inputs. So if anything change in input, it's like a reflect on our output also. So using assign keywords, so out equals to in. So like many like beginners, what they are doing, so they are like confusingly they are like putting that input on like left hand side and output on right hand side. So before like writing, just recall that syntax, that always output should be on left hand side. So yeah, that's it. So this is like wire simulation. So just I'm just submitting it. So this is like uh we get status success here. So this is like basic question. So that's why I'm not implementing any uh, task or function. So that one thing you always have to practice, that it is better to always use like function or task solving questions. So it's better like you can just call it everywhere. But it's like normal basic questions, so that's why I'm not including it. So let's go to like next questions. So question is like wire or something. So what is in that? So create a model with three input and four output that behaves like a wire that makes this connection. So we have to create connections. A assigning to W, B is assigning to X, again then B is assigning to Y, and C is assigning to Z. Okay, so we are okay. This model we have to create where A, B, C are the inputs. A is like continuously driving to W, B is continuously driving to X and Y both, and C is driving to Z. So this is like easiest question again. So I have to write like one, two, three, four lines. So instead of writing four line, I'm just using multi-bit writing. So I'll just tell you like how to write like multiple bits. So 2, 3, and 4. So that's 4 line. Just press Alt on your keyboard and just drag it. Okay, so you select that 4 line. Then write. You can like continuously write that like 4 line. Like you can write 4 lines at a time by using that. Just assign equals to. So I'm just changing the name later. So firstly, I'm just s- assigning. So what is my output? So W equals to A I am assigning, and after that I will change that all thing by pressing escape. You can just came out from that mode. So after that, all output I will just change X Y Z. So last one is like my C. The middle ones are like B. So that's it. Okay. So like before that, like indentation should be there. Like it's not like a fixed rule to that indentation. It doesn't affect your coding, but it's like good to see. So this is our code. Just submit it. It's executing. So this is like reference and man. So both are like matching. So we get the status of success. Okay. So let's go to not get. Okay, we have to create a one not get. Okay, so easy one. So by expression we are like I'm doing here. You can also do that with a different way that there for not get using expressions and all that. You can also do that, but here I'm just using operators. So write that assign. What is my output name? Out equals to whatever my input. Negation sign. So this is negation sign. Then in. So whatever my input, giving the opposite of that means not get functionality. So just submit it. Yeah, no mismatch. Status success. Okay. So one more way that you can also use your exclamation mark. If you use same output like as not get or like pivot that negation sign, submit it. Let's check it like it works or not. Yeah, you can see that we are using exclamation mark and we get this result. So no mismatch is here. So let's go to and get. Okay, that's simple question. We have to create and get. You can use that via W and when we are saying that. You can also use that also. So first thing we have to use some keyword out equals to a. This is and operator and b. Okay, that is might replace that gas. That's one. So assigning out equal to a and b. Let's submit. Okay, we get status success. No mismatch. You can also use that wand. So I will wand you can use or like directly you can give the name of gate like and gate. So and of. So first we have to write output then inputs and a comma B. So this is the basics syntax. Yeah, that's it. It's like easiest way to, if you don't remember that expression, that like what is the operator for and or, in that way you can directly write the name of gate, and then for output you have to mention. After that you have to mention that inputs. This can be like another way. Or like if you know the like if you are able to remember that operators, so it's like better to use operator. It's like up to you like what you have to use. So next is like NOR gate. Okay, we have to create a NOR gate. Okay, so NOR gate is like OR gate, which is like inverter. So for that uh, declaration of NOR gate, we are using assign, then output name out equals to. So NOR gate is like negation of OR gate. So we are writing the logic for OR gate. So A or B and just negation sign. So this is our NOR gate. Just press the submit. Yeah, no mismatches. You can also do that thing which I told, using NOR output name, then input, and submit it. Just okay. So no mismatch and status success. So like the both way, like what is like your approach? It's depend on that. Like for us, if we have like eaten gates, so at that time we can use that NOR, but we have to perform any functionality or like in behavioral modeling. At that time we are using mostly the operators. So it's like depend on that. Go with XNOR Gate. So create a module that implements XNOR Gate. So we have to create XNOR Gate. So XNOR Gate is like negation of XOR Gate. So if we create XOR gate, so we can negate it to make XNOR Gate, or we can directly use that XNOR Gate operation. So many time people are like forgetting. That's why I'm just telling this, whatever the key one, that XNOR, you can use that XNOR, then output name as out, then input. That's it. Just submit it. Yeah, no mismatch. You can also use that thing. Assign by using operator I'm telling here. Assign output equals to A X or B. So this is my XOR operation. But I have to create XNOR. So I'm just negate it using negation operator and just submit it. Yeah, we get the instructions. Let's jump on the next question. So we have to declare wire declarations. So the circuit have been seen. Okay. What we have to do is not questions. And we have to calculate circuit circuit some mode. Okay. So we have to declare some internal wire and drive through that. Okay. So we have to, okay, so this is our circuit. So A and B is there. So two wires. Okay, so we don't require to this one wire. So when we are like driving some like creating any complex circuit, there are like some internal wires. So these like port wires are there, the input and output ports, but there are like from that there are like some different wires are there called as internal wires. So we have to declare that wire by using wire keyword. We can declare it. So we have to create this structure A and B, and operation is going to OR gate. So we require this wire declaration. We don't require this wire declaration because already this output is like connecting to out. So we can directly take negation of out to the out end. So let's see like how to solve this question. So A and B, we have to create two AND gates. So I'm using assign operator here. Assign. So before that, we have to create two wires that by using wire W1 comma W2. So in assign, we have to for W1. I'm just assuming that this is W1 and this is W2. Okay. So assigning W1 equals to A and B. Again, assigning for the second AND gate, assign W2 equals to C and D. Then they like W1 and W2 or operation, and it's assigning to out. So assign out equal to W1 or W2. Okay. So out N is coming from the out, and its NOT gate is there. So for NOT gate, we have to use negation operator again. Assign out underscore and equals to negation of out. So that's it for the design. So this is like wire declaration, and then after that the functionality we return. So submit it. It's executing. Yeah, no mismatches is here, and status success. So let's go to the next question. 745. Okay, we have to create that 745 IC. So in 745, we have two input, two AND gate, and three input, two AND gate. So P1A, P1B, P1C, like inputs for first, then okay, A, B, C, then D, E, F, again A, B, and C, D. Okay, easy one. So for that, we have to create for these things one AND gate, for these things one AND gate, for this thing one AND gate, for this thing one AND gate, and total four wires we required. So let's declare the wires. So wire W1, comma W2, comma W3, comma W4. So after that, directly assign W1 equals to, we are going with this sequence. So just copy it. Instead of adding and just copying it, you can write also. Just and operator. Okay, then after that assign W2 equals to again assign W3 equals to these things. And assign W4 equals to, okay, so this is like AND gates. After that, we have to drive that out wires W1, W2 to OR gate, and one is going to P2Y and one is going to P1Y. So I'm just writing for the first and assign that output is like P2Y. So assign P1Y, I'll just go with the P1Y first, then P2Y I will go. P1Y is equal to W1 or W2. Then again assign P2Y equals to W3 XOR W3 or W4. That's it. Submit it. Yeah, no mismatch is there. So we get status successful. Okay. So we covered that all basic questions. So next video we are going to these vector questions. So that's it for today's video. So in next video we are just going through the vectors. Thank you for watching.